You are standing on your back deck, feeling that soft, spongy give under your boots, while staring at a $15,000 estimate to replace the entire structure. Today I will reveal to you how to alchemize any piece of wood to be rot-proof and termite-proof forever using a $2 box of common mineral salt, but stop. If you just dissolve this salt in water and brush it on, the first rainstorm will wash it away, and the fungi will finish their meal. You must use the secret diffusion protocol to lock the minerals inside the wood cells forever. I will explain that exact glycol-boron ratio shortly. But first, you need to understand the predatory lumber cartel that is engineering your deck to fail. This is the lost blueprint. Your deck is rotting, your fence is leaning. Your house's foundation beams are being eaten by termites from the inside. The lumber industry tells you to buy pressure-treated wood, which is loaded with toxic copper that eventually leaches out. Or the paint industry tells you to apply a $100 gallon of sealant every 2 years. It is a subscription to a failing structure. You pay endlessly, the wood still dies. This is not inevitable. This is engineered obsolescence in construction materials. A standard deck replacement costs $15,000. Maintenance stains cost $500 every 2 years. Over 20 years, you spend $20,000 just to keep wood from doing what it naturally does, which is return to the earth. The industry relies on this decay cycle. They want your wood to fail, so you have to return to the lumberyard. If you knew how to permanently mineralize wood against biological attack using chemistry available at any hardware store, their entire recurring revenue model would collapse. The mineral they buried is boron, specifically borax and boric acid. Boron is a natural salt that is 100% toxic to the fungi that cause rot and the protozoa inside a termite's gut that allows it to digest wood. If boron is present in the wood cell, nothing can eat it. Period. The timber industry knows this, but they prefer selling you low-grade chemical treatments that expire. They need you rebuying materials every decade. Wood decay is biological. It is not age, it is not weather. It is fungal digestion. Fungi are living organisms that consume cellulose. Wood is cellulose. When moisture is present, fungal spores land on wood surfaces. They germinate. They send thread-like structures called hyphae into the wood fibers. These hyphae secrete enzymes that break down cellulose into simple sugars. The fungus absorbs these sugars. The wood loses structural integrity. It becomes soft. It becomes spongy. Eventually, it disintegrates completely. This process is called rot. It is biological consumption. Termites are insects, but they cannot actually digest wood on their own. Their guts contain symbiotic protozoa. These single-celled organisms produce the enzymes needed to break down cellulose. The termite eats wood. The protozoa in its gut digests the cellulose. The termite absorbs the nutrients. Without these protozoa, termites would starve eating wood. The relationship is obligatory. Kill the protozoa, and you kill the termite colony. Boron disrupts both processes. For fungi, boron interferes with cell membrane function. Fungal cells cannot maintain proper osmotic balance in the presence of boron. They dehydrate and die. For termites, boron is toxic to the gut protozoa. The protozoa die. The termites can no longer digest wood. They starve. The colony collapses. Boron is a biological weapon against wood-destroying organisms. It is selective. It does not harm humans, pets, or plants at the concentrations used for wood treatment. It only kills the specific organisms that consume wood. The challenge is getting boron deep into wood cells. Wood has a cellular structure. It is not a solid material. It is millions of tiny tubes bundled together. These tubes transported water and nutrients when the tree was alive. Once the tree is cut, these tubes are empty but intact. They form a complex network of channels running through the wood. Boron must penetrate these channels and remain there permanently. Water is the obvious carrier. Dissolve borax and boric acid in water. Soak the wood. The water carries the boron into the surface cells, but water has high surface tension. It does not penetrate deeply. It sits on the surface. When the water evaporates, most of the boron is left on the outside. Rain washes it away. The core of the wood remains untreated. This method fails. The lumber industry uses pressure treatment. They place wood in a sealed chamber. They flood the chamber with chemical solution. They apply massive pressure, forcing the liquid deep into the wood cells. This works, but requires industrial equipment costing hundreds of thousands of dollars. It is not accessible to individuals. The chemicals used, typically copper compounds, are toxic and eventually leach out. The treatment is not permanent. The suppression of accessible boron treatment was deliberate. During the mid-20th century, boron treatments were well known in industrial timber preservation. They were used in mines, railroad ties, and structural timbers, but they were not marketed to consumers. The paint and stain industry promoted surface treatments that required reapplication. The lumber industry promoted pressure-treated wood with planned obsolescence built in. Boron diffusion, which creates permanent protection, threatened both industries. It was quietly ignored in consumer education. Hardware stores stock borax in the cleaning aisle but never mention its wood preservation properties. Now I will give you the exact glycol boron diffusion protocol. This is the precise chemistry that drives boron salts deep into wood cells and locks them there permanently. Follow these ratios exactly. Deviation will result in incomplete penetration or wasted materials. Step 1 is ratio preparation. You need borax and boric acid in a 60-40 ratio. For every 6 parts borax, use 4 parts boric acid. If you measure by weight, use 6 ounces of borax and 4 ounces of boric acid. This combination provides optimal boron concentration. Borax is sodium tetraborate. Boric acid is a weaker acid form of boron. Together, they create a buffered system that maximizes boron availability. Step 2 is carrier selection. This is the critical innovation. You cannot use water. You must use propylene glycol or automotive antifreeze that contains propylene glycol. Propylene glycol is a small organic molecule. It has low surface tension. It is hygroscopic, meaning it attracts and holds water. These properties allow it to penetrate wood fibers far more deeply than water. It carries the boron salts with it into the core of the wood. Step 3 is heating and dissolution. Pour 1 gallon of propylene glycol into a large stainless steel pot. Heat it to approximately 150 degrees Fahrenheit. Do not boil it. Hot glycol dissolves the boron salts much faster than cold. Add your measured borax and boric acid to the hot glycol. Stir continuously until completely dissolved. The solution will be clear with a slight viscosity. Let it cool to a safe handling temperature around 100 degrees before application. Step 4 is wood preparation. The wood must be clean and dry. Remove any existing paint, stain, or sealant. These coatings block penetration. Use a pressure washer or sander to expose bare wood. Let the wood dry completely. Moisture in the wood will resist glycol penetration. And wait for at least 3 dry days after cleaning before treatment. Step 5 is application. Use a paintbrush, roller, or pump sprayer to apply the glycol boron solution liberally to all wood surfaces. Soak it. Do not just coat the surface. Apply until the wood stops absorbing. End grain, where the wood tubes are cut open, will absorb the most solution. These areas are most vulnerable to rot. Give them extra applications. For maximum protection, apply to all 6 sides of each board if possible. Step 6 is dwell time. After application, the wood must sit undisturbed for at least 72 hours. During this time, the glycol diffuses deep into the wood cells through capillary action. It carries the boron salts with it. The glycol evaporates slowly. As it evaporates, the boron concentration inside the wood increases. Eventually, the boron salts crystallize inside the wood cells. They become a permanent part of the wood's internal structure. Step 7 is curing and finishing. After 72 hours, the treated wood is protected internally. The surface may feel slightly tacky from residual glycol. This will evaporate over another few days. Once fully cured, you can apply paint, stain, or sealant if desired for aesthetic purposes, but these finishes are optional. The wood is already protected from biological attack. Surface finishes only provide color and UV protection. They do not add structural durability. The chemistry is elegant. Propylene glycol is a penetrating carrier. It has low molecular weight and low surface tension. It wicks into wood cells through capillary action. Boron salts dissolved in glycol are transported deep into the wood structure. When the glycol evaporates, the boron remains. It crystallizes within the cell walls. This creates a permanent toxic environment for fungi and termites. They cannot consume the wood without poisoning themselves. The wood becomes biologically inert. The financial impact is dramatic. Pressure-treated lumber costs 50 to 100% more than untreated lumber. A deck built with pressure-treated wood costs $5,000 to $10,000 more than untreated lumber. The boron treatment costs approximately 50 cents per square foot of wood surface. For an average deck, total treatment cost is under $100. The savings are enormous. For new construction, buy cheap untreated lumber and treat it yourself. For existing structures, treat them in place to stop decay and prevent future rot. The environmental benefit is significant. Pressure-treated lumber uses copper compounds, chromium, and arsenic historically. These are heavy metals. They leach into soil. They contaminate groundwater. They are toxic to plants, animals, and humans. Boron is a naturally occurring mineral. It is used in eye drops and contact lens solutions. It is safe at treatment concentrations. It does not leach significantly once crystallized in wood. It poses no environmental hazard. The durability is permanent. Once boron is diffused into wood cells, it does not wash out. Rain cannot remove it. It is locked inside the cellular structure. The wood remains protected indefinitely. Pressure-treated wood degrades over decades. The chemicals leach out. The protection diminishes. Boron-treated wood does not degrade. The boron stays. The protection is lifelong. The broader lesson is about accessible chemistry versus industrial monopoly. The lumber industry wants you believing that wood preservation requires expensive industrial processes, that you must buy their products, that DIY is impossible or inferior. But chemistry is accessible. The compounds are available. The process is simple. Heat, dissolve, apply, wait. You can preserve wood permanently for pennies. The modern world convinced you that wood inevitably rots, that replacement is normal, that maintenance is eternal. But shipbuilders and bridge engineers knew better. They treated wood with boron salts. Their structures lasted centuries. This knowledge was systematically hidden from consumers because permanence threatens recurring revenue. By using this $2 mineral alchemy, you refuse the $15,000 lumber trap. You bypass the toxic paint cartel. You reclaim a forgotten industrial secret that preserves your home for generations. Your deck becomes a permanent asset, not a recurring liability. The box of borax in the laundry aisle is more powerful than a truckload of pressure-treated lumber, because the truth is simple. When you understand cellular diffusion, you do not need their engineered decay. This is the lost blueprint. The vault is open. The knowledge is yours. Take your structural independence back.